So I'm still gonna work my way through the TypeScript files or slides. I think it's probably going to take me all of today's lecture. If not, then we can move on to the next topic, which is the CDK framework. I'll just introduce it anyway. So let's continue with these slides here. I suppose before I dive into it, I should offer you the opportunity to ask any questions that you might have on last week's lecture. I'll accept maybe questions on the lab as well, but if they're kind of general questions, I'll leave it open to you. Now, I know some of you may not have a microphone, so I guess I should allow people to, if they want to type questions into the chat. I'll just check it before I begin the lecture. Either way, are there any questions, I wonder? Let's see, chat. I don't think there is, so I'll push on. Right, so what do we know about TypeScript? We know that it starts off with using annotations. Okay, there are these primitive types which come with every language, and then there are object types. Then I briefly talked about this this type hierarchy. I want to come back to that actually in a second, just to give you a sense of the what's called the any type, which does actually arise every now and again, mainly in the form of an error, but I'll just come back to that. I'll just spin through the slides here before I do that. It's all about type annotations, this postfix syntax that we use to declare the type of a variable. We can use that on data variables. We can use it on functions as well, function parameters, and on a function's return value. We have a way of declaring typed arrays as well using the subscript syntax. Maybe the arrow, this subscript syntax that I spent forward, sorry. Subscript. Oh yeah, this subscript syntax here. That's fine. We have classes. I didn't talk much about those because classes are classes are classes, and the syntax is very like Java. And as it turns out, we won't be using classes, I don't think at all. In this module, we have interfaces, which you were very familiar with from Java. They have the exact same meaning in TypeScript. We have interface data types, which is something new for you in TypeScript. It's a way of enforcing a structure on a data object. You can be specific about what properties a data object must have, and it's a must, as in the compiler will complain if you're missing certain properties from an object, if you have declared that the object is of a certain type. And also you cannot add additional properties to an object of a particular interface data type. Type aliases. Now, type aliases, we said, overlap with interface data types. There's a lot of people that wonder why a certain syntax is allowed for type aliases. For example, when we look at this example here, that's the exact same as an interface data type, and people aren't really sure why the designers include this in type aliases, but type aliases have other uses as well, and it's the other uses that we tend to make use of type alias, although I often write this style as well. And I have two examples of other use cases for the type alias syntax. And we'll see another example of it later on in this lecture. Type inferencing was this win factor really, whereby you can omit the type annotation syntax in many cases, and it's really only through experience that you start learning when you can leave it out. And anyway, the compiler will always complain if you left out type annotation. It will complain usually by saying it cannot work out what type a particular variable is, and therefore it's going to assume that it's of the any type. And that's really an error which you need to fix. You need to try and help the compiler to work out, to infer the correct type for a variable. But if it, as I said, to repeat myself, if it cannot infer a type from the various types that you have defined, plus the types that are built into the language, be they primitive types, then it will default to the any type, and it will tell you that it is inferring the any type on variable X. And that really is an error. Now you can turn off those type of errors through configuration, but you shouldn't turn it off really. You should try and fix that problem somehow, depending on the nature of whatever the problem is. So that's type inferencing. And I think we kind of finished up around here talking about functions, and that's probably as far as most people would have gotten in the lab as well. Again, I'll just pause in case there are any questions. Let's go back to the code sample, the sample code, and I want to go way back to this one here. And so if we take, for example, this one, okay, that's fine. I'm declaring a variable and I'm saying its type is number. And then I told you the last day that if I now enable this line here, then the compiler is complaining and it's telling me, I open up my problems page. The problem's gone. Let's see. Yeah. And so it's correct. It's telling me, look, you can't assign a string to a number. But let's supposing I did this, which I shouldn't. If I change this to the any type, because that is a type that's built into the TypeScript language, then my error is gone and the compiler is happy. Now, of course, you should never do that, though. You should never have either explicitly or implicitly, and by implicitly, I mean inferred. You should never have a variable whose type is the any type, because really you're back to JavaScript if you're doing that. Remember that the whole this dynamic type nature of JavaScript was that when you declare a variable, you could assign any value to it, and subsequently you could assign a completely different type of value to the variable, and the JavaScript didn't worry about that, but that invariably caused problems. So the any type is an actual type that you can explicitly attribute to a variable, but you never should. It's bad programming. And also that point that I made there earlier on, when the actual compiler will tell you down here that it is inferring the any type on a variable that you haven't explicitly declared a type on. It's inferring the any type on it. And it's actually, that is an error that you need to fix. I don't have an example where that inference shows up, but you probably come across it, or you may come across it at some stage. Okay, that's just kind of by the way to this any type does actually exist within the language, but we should never do that. So we'll go back to there, and then this is indeed an incorrect statement. So I'll take that out as well. Right, let's pick up roughly where we were the last day, which is on functions. And we know some of the stuff about functions. I go through this. So if we take the very simplest example, where we are explicitly declaring the return type of the function, and we also are declaring the types of the parameters. I can't think of an example where the parameters can be inferred in the function declaration. I think you really always need to state the types of the parameters. Down here, I'm just showing an example where I'm not explicitly declaring any return type, but as we know, the compiler will infer the return type based on the return statement or statements that are in your code. And if we do our Command K, Command I on this one, Command K, Command I, then it's getting it correct, isn't it? Yeah, so it's inferring the return type over here. That's fine. Arrow functions you would have come across. So arrow functions were introduced into JavaScript in around 2015, 2016. And you know the arrow function syntax where we use this arrow symbol here between the parameters and the body of the function. And so I'm just showing you an example here of using type annotations on an arrow function. Yeah. So again, this is the return type. And that's consistent with what's being returned here. I don't have any return statement here. How come? Like, that's the function, right? The entire function. But I don't have a return, like the return keyword isn't being used anywhere. But I can tell you that what is returned is that. Anybody know why that's going to work? Or if I say this is really a JavaScript question rather than a TypeScript question. Suppose I put in another line here and I go, let's a equal to 2. Now I'm getting lots of errors down here. All right. The errors now are actually, it's more a JavaScript thing than a TypeScript thing. What extra do I need to do now to this function? It now has 2 lines of code. It only had 1 line of code.
Because it's in a Lambda function, you can only be a single line statement.
Yeah, that's right. If you got an arrow function and there is only 1 statement or 1 line of code in that function, then you can leave out lots of the syntax associated with arrow functions, which is you can leave out the curly braces that are embracing the body of the function. I've no curly. You would usually have a curly brace here and a closing curly brace down here. I don't need those when it's only a single line of code in my function. Also, I don't need the explicit return keyword because the JavaScript runtime will deduce that the return value of the function is whatever the evaluation of the single line of code is. So if we go back to where we were, the JavaScript runtime will deduce that what it should return for this function is this expression, right, which is just a string. Okay, that's fine. So anything else? Okay, this is a kind of a makey-uppy function, right? I've got a function called rotate, and the idea of the function is you give it a source string and you give it an axis. And what the function does is it looks for the occurrence of the axis in the source string, and then it kind of rotates the string around that axis and returns the result of that rotation. Now, just for demonstration purposes, I decided my axis could be a string or it could be a regular expression. If it's a string, then what the function does is it simply looks for that axis string in the source string and rotates around it. If it's a regular expression, then it looks for the occurrence of a particular pattern in the source string and it rotates around that part that it has matched up with the pattern. Okay, you can look at the detail of it. It's really just JavaScript code. It's not, there's nothing TypeScript. Oh, well, okay, obviously, you know, this is TypeScript, all right, but if we look down to the body of the function, there's nothing particularly TypeScript-y about it. I'm assuming people have come across regular expressions before in some other language. If you haven't, you should read up on them really, but I'm pretty sure you have at some stage. Other than that, you know, it's just an arrow function with stuff in it. Is there anything that I need to pick out? I don't think so. You know, this is all just regular JavaScript stuff. You know, what am I doing? Sorry, I'm taking the source string and I'm splitting it around its axis. Oh yeah, I did just want to mention that. All right, this statement here, right? You might think type of there is an operator, and it's not actually a TypeScript operator. It's an operator that's available in JavaScript. The TypeScript operator, what it does is it examines the variable that you're passing to it, and it will determine whether it's A, a string, B, a number, C, a Boolean, or D, an object. And it could be, the object could be anything, right? The reason I need to do that is I need to work out, the purpose of this statement here is to work out when the function was invoked, was the axis that was passed into it, was it a string or was it a regular expression? If it's a regular expression, then that really, that's it. That is instantiated as an object. We don't have to worry about how regular expressions are represented in memory, but I can tell you they are represented as objects. So the purpose of that line was to work out whether a string or a regular expression was passed in as the axis. But this type of operator is just a JavaScript thing. You may not have come across it, but it's there. And you can look at the detail. Okay, so for example, if that's my source string, and when I'm invoking my rotate function, I'm actually passing in the regular expression. Look for 2 consecutive digits in the source string and make that your axis. And so 1, 2 there matches up with 2 consecutive digits. So it'll rotate around that. In the second example, I'm passing it, looks like an email address. And when I call my rotate function, this time I'm passing it a string. Happens to be a string of just 1 character, but it could be more than that. And so it'll rotate around the @ symbol. And, you know, okay, let's just, for the sake of it, spend maybe too much time explaining that because, as I said, it's not particularly TypeScript-y stuff. But let's just run it anyway. As a matter of interest, did anybody have to run their TypeScript code using the command that I'm using? Was everybody else able to run their TypeScript code using the other command. Does anybody have to use this minus loader and all this stuff? Hopefully not. I'm hoping that everybody else got it to work in the normal way. Okay, source. What number are we on? 01. And you can see, look, that became that, and this guy became this. Yeah, so looks like it's kind of working okay. All right, good. There's nothing particularly fancy from a TypeScript point of view. So let's move on to higher order functions. What's a higher order function? A higher order function is a function that takes a function as a parameter. And we often just generically refer to that function parameter as a callback, because presumably within the main function, it invokes the callback at some stage. But anyway, a higher order function is a function that takes a function as a parameter. Now the question is, how do we tell the TypeScript compiler what type the callback is? Because it's a function, it's not a primitive, it's not an object, it's actually a function. And so the syntax, which can be a little bit tricky to get used to initially. Here's an example, right? I've got a function called print to console, it doesn't do anything interesting. It looks like it takes two parameters, a parameter called text, which is of type string, and a parameter which I just generically refer to as callback. I could call it anything. And here's how I declare the type that the callback needs to be. And what this is saying is the callback needs to be a function which takes one parameter of type string and it returns a string. Yeah, so this syntax here is the way to describe essentially the signature of a function. As well, this example is demonstrating when a function doesn't return anything. So the void here is telling me that this function here doesn't actually return anything. Again, if we left out that, it would infer that anyway. And indeed, there is no return statement here. Okay, so that's this. That's the new part in this. What have we got down here? We've just got another example of a function called array mutator. Maybe I'll go back to the code now at this stage. Although at the bottom of the slide there, I'm saying we can use type aliases to improve the readability of callbacks signatures. You know, if the signature was, you know, if this parameter here was had to be a function that took, I don't know, 4 parameters and returned something complex, then, you know, it becomes very unwieldy just typing the whole thing out there. It would be nice if we could come up with a name or a name for this signature type and then just use that name. And that's where type aliases come in. To here. That's the example that we had on the slide. So move on from there. Okay, so like here I'm invoking my function, and indeed the first parameter is a string, and my second parameter is a function which begins here and ends there. And if we look at the function that I've highlighted, it's kind of respecting the signature that I've specified up here. because this function is a function that takes one parameter of type string and it's returning whatever to uppercase returns, which is a string. Okay. I've actually just commented out this. If I bring this in, uncommented. And the point I'm trying to demonstrate here is that the compiler will complain. It will actually check the signature of the function and tell you that it's not matching up to what you stated. It's essentially complaining here about the function that I'm passing to it, because if we look at it, here's the function that I'm passing, and look, the first parameter is a type number. That's no good. Okay, it's returning, and it's returning a Boolean, it looks like. It's returning this. So it completely fails completely fails this requirement. I'm kind of skimming over them, but you know, sometimes it can be easy to interpret these messages, these error messages. Sometimes it just takes experience, but like it's saying that the argument of type number, I just mouse over it. The argument of type number does not match the argument of type string, essentially. That's kind of what it's telling you there, and it's probably telling us about the return type as well, that doesn't match up. Okay, so the compiler is able to help us with callbacks as well, with higher order functions. Here's another example. So the idea of this function is that I want to be able to pass it an array, and I want it to return a mutated version of that array. And the mutation is dictated by a callback that I pass to it. So here's the first argument. Okay, I pass it an array of numbers. And here's the callback, which I've called mutator. A mutator, it will, as I said, it's going to map over this array and mutate each element in it. That's the idea. And the mutator has to be a function that takes a number and returns a number. And you can see there, it's just doing mapping over it. And here, when I'm calling it, I call my array mutator, I pass it an array of numbers, and I pass it this particular function. Yeah, so it looks like it's bumping everything up by 10, factor of 10. Here, I'm just showing you, I'm actually, what am I doing here? Oh yeah, I'm just declaring a function. This is actually going to be my mutator, but I'm declaring it separately. It takes a number, this function takes a number and returns, what's that? What am I doing there? Can anybody explain? So the function takes a number and it does something to the number. What does it do to the number?
That statement evaluates the true, execute the first one after
the question mark, yeah.
After the question mark,
yeah.
else the second one,
yeah.
after the colon.
What's the name of that question mark there and the colon there? They kind of go together hand in hand. What's that? What's the combined name for that? And again, this is a JavaScript thing. It's not a TypeScript thing. I may not remember actually. It's called the ternary operator, and you're right. What it does is it evaluates this, and if it's true, then it executes that. So it's like an if else. It's short for if else. Otherwise, it executes that. Okay. Again, that's just all JavaScript. And here we go calling our array mutator with our array and with our mutator function. Now, where type aliases can be useful here is, see what I'm doing here? I'm actually declaring using type aliases, and any statement that begins with the keyword type is a type alias statement, and what we're doing is declaring a type. In this case, the type, okay, that's its name, and it's actually declaring the signature for any function, okay? So mutator function is any function that takes one argument of type number and returns a number. Now, I can now use that rather than, I can actually replace all of that code by my type alias, by my type alias. And just the code reads a little bit better, because if there are lots of places in my code where I have a callback that's of this nature, then rather than, okay, you can cut and paste it, of course, but might be nice to actually come up with a descriptive name for it. And that's really what we're doing down here. I got it. Yeah, that's what I'm doing here. And so that's another example now where type aliases can be very useful. Like what it really allows us to do is to write more readable code. And here I'm using it actually. Look, I'm saying that this second argument, which I've again called mutate, its type is taken from there. Okay. Well, I'll ignore this stuff for now, actually. Go back to promises later on. So back to my slides. So that's higher order functions, and the requirement is that the callback, and of course there could be more than one callback, that we pass to our function, we have to declare essentially the signature. We've got to put some type related information on the signature of the callback. Next thing is optionals. So going back to interface data types, remember interface data type is a type that defines the structure of an object. But the thing with interface data types that we've looked at so far is that every property within the type was mandatory. Sometimes there may be properties within an interface data type that are optional, hence the name optionals. So again, if we look at the example on the screen, we are defining using the interface data type syntax. This also applies to type aliases. We're defining a type called user, and it has an ID property, which is mandatory. But if you see here the question mark after email, that's telling us that the email property is optional. So you could have an instance of a user that does not have an email property and one that does, and the compiler won't complain about the one that doesn't have the email address. Also, we're saying that social is an optional property, and the social property is a nested object, it looks like. However, if the way you interpret all of this is, if an instance of this user type does have a social property, then that must have a Facebook property within it, and it may have a Twitter property or an Instagram property. So these are optional within the social. It may not have social at all, but if it does, the social must have a Facebook, and it may have both or one or neither of these two. And it must have a status property. So the optionals can be anywhere within the overall structure. And we can also use the optional syntax, the question mark, with functions, because functions in JavaScript can actually have variable lists of parameters. And that carries forward then into TypeScript. The only thing though is that the the kind of optional parameters in a function have to be the trailing ones. They can't be kind of in the middle of the parameter list. So if I go back to our source code for some examples of optionals, although I think it's a straightforward enough thing to understand really. So here we are in optionals. That's the user one that we looked at. And so Joe here looks like Joe doesn't have an email or doesn't have a social, well, he does have a social property and Facebook within it. So that's fine from the compiler's point of view. And it's a type user, of course. The compiler doesn't complain and there are no compiler errors down here. Jane has an email. Look, they're all very straightforward, so maybe rather than talking through them. Here we're using the optional syntax in a function. So it looks like the first parameter is of type string, and the second parameter is of type string, and the third parameter, because it's got the question mark here, is an optional parameter. So this function can be called with 2 parameters or 3 parameters, and it'll work in both cases. Now you do have to be careful within the body of a function that has optional parameters. It doesn't arise in this case, but if you're doing some kind of evaluation of the optional parameter, then you have to build in the fact that sometimes that optional parameter will be null. Okay, and the compiler will actually warn you about that. As I said, it doesn't arise in this case because all I'm just doing is console logging stuff, but it can arise. And we'll see a little bit later on actually where optionals, can cause you a little bit of a headache in the sense that you need to be very careful with how you're doing your processing, but it's really the compiler is protecting you from possible runtime errors that could arise if you don't deal with the null case for be it optional parameters or optional properties within an object. Okay, here I'm calling my function with 2 parameters. Here I'm calling with 3 parameters. I'm going back to my type aliases in relation to all of this, just to give you, just show you lots of examples. That's my rationale here. If I show you plenty of example code, then hopefully you kind of pick things up as you go along. So all I'm doing here is, okay, I'm defining a type called social handler. Now again, sorry if I keep repeating myself, but okay, I'm using type alias syntax for this, but I could have easily used the interface data type syntax for this. This is just a regular structure. Yeah. So I've got a social handle type. I've got an address type. Then I've got a contact type, which is, I'm saying either of type social handles or address. Now I have to use type alias syntax to say that. So a contact could be a that or a that. Then I've got a new type called user version 2, and their user version 2 has a contact property, which is of type contact. But of course, we know now that this thing here could be an address or a social handles structure. And this is, this is how you kind of write TypeScript code once you start getting experience, I guess, with it. You really leverage type aliases and interface data types as much as you can. I could have taken away that and put in all of this stuff, and said that and that put all of that somehow inside my user version 2. But defining these small types is a better programming style. Okay, so I've got a user version 2 type, and I've got instances then of, so Kyle is of type user version 2, and okay, it looks like he doesn't have, sorry, his contact is in the social handles. It's following the social handles structure. So compiler is happy about that. Jenny has her contact looks like it's following the address structure. So the compiler is happy about that. I've got a function here. Here's something that's kind of nice now actually about TypeScript. So I've got this function called getContact, and I pass it a user, and I pass it, oh, that's all I pass it. I pass it an instance of user version 2. And what I wanted to return to me is the contact details of that particular user in stringified form. Okay, so we know now that the contact information inside in this object, it could be an address or it could be a social handles. And clearly my code needs to determine which one it is in order to stringify it. And so I've got a statement here. And again, this is regular JavaScript because the in operator, all the in operator is it examines the object on the right to see if it has a property called that. So I'm indexing into user.contact, and I'm checking to see, does user.contact for the particular user that's passed into this function, does it have a street property? If it does, then we know that the contact is of type address. And so when I'm stringifying the contact, I'm pulling out the well, okay, this is saying it's an address, so that's kind of informing the user. Okay, I'm stringifying the whole thing, but the fact that I can say it's an address in the return string is only because this has evaluated to true. Now, here's the TypeScript thing though. If I do Command K, Command I on this, watch what happens. The compiler has worked out that it's actually of type address, right? It's kind of deduced that from, and that's based on the if statement. And I'm trying to get rid of that. Just give me 1 sec. You would have thought that when I'm assigning user.contact to this variable here, contact, that property is of type contact, but contact could be one or the other. And because I have essentially narrowed it down, because this is evaluated to true, I have narrowed it down to the fact that contact is actually an address. And the compiler has also worked that out for itself. Don't know if you can appreciate what I'm trying to say here. Equally here, right? Like if let's see, sorry. Oh yeah, because I'm returning here, that means the only time the code will execute this is if the contact details of the user is of type social handle. And so equally, if I do Command K, Command I on this guy, it's worked out that it's of type social handle. That's referred to as type narrowing in the language of TypeScript. And it's I guess it's just give you an insight into how powerful the compiler is. We'll just pause for a second in case there are any questions about that. No, okay. Literal types, again, I'm only including this just to show you lots of examples. So I've got a literal type called, this is back to type aliases now. I keep going back to type aliases, it seems, but they are very powerful. Here's another use case for type aliases. Again, our statement is beginning with type, so it must be type alias. But this is what's referred to as a literal type. Sorry, if I go back to my slides. Yeah, my slides are talking about union types and type literals. We've actually seen them already, but I'm kind of including them formally here. A union type, we're saying, are used when a value can have more than one, can be more than one single type. And maybe the example on this on the slide is actually just as good as the one in the code. So I've defined a type here called size, and I'm saying it could be a string or number. And I've got a variable called glass size. It's of type size. And I'm assigning it the string medium. So that matches up with this here. So the compiler is happy with that. I've got another variable called bottle size. It's of type size as well, but I'm assigning it a number. And the compiler is happy with that as well, because my union type here, this is an example of a union type, says it could be a string or a number. And here's another example of a union type. And again, these are the kind of things we should leverage as much as possible in our code. So that's a union type when you've got this kind of ORing of a number of different types together. And they don't have to be primitives. They happen to be primitives here. But anyway, I mean, we just saw in the source code that we were looking at there in VS Code, we had the contact type, which was of type address or social handles. So it can be complex types as well. Literal types, again, we define them using the type alias syntax, is when you're actually pinning down specific values that instances of a literal type can be. For example, I've got a type, I'm declaring a type called degree nomination, and I'm saying it's either equal to the string that, or the string that, or the string that. Note what we're defining here now is a type. This is a type. Later on, then we might declare a variable of that type, and that variable can only have that value, or that value, or that value. If you try and assign anything other than those three strings to that variable, then the compiler will complain. So a lot of what TypeScript is about in relation to type aliases anyway is seeing opportunities to define types using the type alias syntax, whether that be union types, literal types, you know, the function signature types that I showed you earlier on. That's when you start writing good TypeScript code. And again, I don't expect you, from what little time we will have on TypeScript, to be highly proficient TypeScript programmers, but you know, the more you practice, the better you get. Just quickly go back to here. Okay, so type department equals engineering or that or that. Then I'm declaring a variable, sorry, a staff member. Oh yeah, I'm declaring a type called staff member. And I'm saying staff member, the way you interpret this here now is staff member can be an object whose structure is the same as that, plus an additional property called department, which is of type department. So the and symbol here is allowing me to kind of join two structures together in order to define a new structure. It happens to be that the structure on the right here just contains one property, but there could be more than that. So this guy this type will have all the properties of this plus an additional department property. And then I'm declaring some, what am I declaring? I'm declaring an array of staff members. What is that about, I wonder? That triple dot, what's that called? Again, it's a JavaScript thing. That's called the spread operator. And what the spread operator does is it takes this object and, as the name suggests, it spreads the individual properties of that object into this object here that I'm declaring. I'm declaring an object here that begins there and ends there. So, and this was just a convenience for me, rather than me typing in another, whatever the structure of user v2 is. User v2 had quite a lot of properties. So rather than me typing in all examples of properties within a user v2, I'm just reusing the Jenny object that I defined earlier on in this script, and I'm just spreading out those individual properties. And of course, I'm adding on my department property because this says a staff member object has to have a department property. So Jenny is in department engineering. Kyle again was an object I defined earlier on. Kyle is an object now, not a type, but it is an object. When we look at the declaration of Kyle was an object of type user v2. So this object has all the properties that I need inside in an object of type staff member, and it has a department. And I've just got a function here, which looks like, what does the function do? We give it an array. We give it, sorry, what do we do? Oh yeah, okay, it's probably not great. What this function does is it goes through this array and it picks out those staff members that are in the particular department that we pass in as an argument. Because look, it's filtering over the company. Sorry now. And again, here we're invoking our function. That's the function there. We're invoking the function, the first argument, clearly the first argument, well, there's only one argument, sorry. The argument that we're passing to it, because it's of type department, then it has to be exactly equal to either the string engineering or accounts or sales. If I pass it anything else, if I do, let's say if I mistype this. Yeah, then my compiler is complaining here because that is not a valid instance of the department type. And this is another good example of the beauty of TypeScript versus JavaScript. You know, it's really keeping an eye on us that we're writing sensible code. Do that. Next topic is generics. The first place, generics. Lots of languages have this generics characteristic or aspect to them. I asked you there the last day whether anybody, or sorry, whether you had studied Kotlin, the Kotlin language, anywhere along your preceding years. I think you said that you hadn't, which Kotlin is the language that's used for developing Android apps, and there is an Android app development module I know in fourth year. I don't know if it's the first semester or the second semester, but if any of you are or will be doing that module, then you'll be writing lots of Kotlin code, and Kotlin kind of uses generics really upfront. Whereas in other languages like TypeScript, you could write a lot of TypeScript code without needing to use generics. Turns out, though, that we will see generics quite a lot in what we are going to be doing eventually with TypeScript, coincidentally. The very first language to bring about this concept of generics was the Java language many, almost decades ago now. So it was the first language to introduce it. And what generics are all about is trying to maximize reusability of your code. So I'm saying there in the very first bullet point, just a general point, that a major part of software engineering is about building components that have well-defined interfaces, but that can also be reused in different scenarios. And that's what generics allow us to do in our programming code. It allows us to reuse, in our case, reuse classes, reuse functions for and reuse types, in different scenarios. So it allows us, the second bullet point, generics allow creating type variables to create classes, functions, and type aliases that don't need to be explicit about their data types. I shouldn't really be reading code. Let's look at a simple example here. We've got a function and we're going to use generics on it. Now, I've purposely given this function a meaningless name because we don't want to get bogged down on that, and I'm not giving you the body of the function, but whatever processing, whatever kind of logic is within this function, we've realized that that logic is useful for different data types. Okay. And so rather than defining the function for each of the different data types for which this function is going to be useful to us, we can use generics, and what it will allow us to do is just define the function once and reuse it for the different data types for which this function can be used. The way you tell the compiler that this is a function that leverages generics is by means of this here. So the angle bracket, close angle bracket. The T here is what's called a type variable. See here I'm talking about, I say a type variable. And that's kind of confusing because we tend to associate variables with data. We assign a variable a piece of data, whether that be, an object or a number. But in this case, a variable can be assigned a type. So T here is just a variable name, and you could use any variable name that you want to. And it doesn't have to be a single character. It's just the convention, but you can use any style you want to. So T here is what's called a type variable. And which will only be, this variable will only be assigned a type at invocation time. And here we're actually invoking the function, and we're saying we want the type person to be assigned to the type variable T, and wherever T appears, either in the parameter list or in the body of the function, then replace T with the type person for this particular invocation of it. And you can see in our case, the first parameter is of type T. Second parameter is just a number. And okay, I purposely left out, but inside in the body of it, we might have a variable which we declare its type is T, and it's assigned, I don't know, something based on the return value of a function that we invoke. So this is generics when applied to a function. Although this syntax here, angle bracket, close angle bracket, and in between we have the type variables. There can be more than one. In this case, there isn't. So, an example. So rather than just diving straight into generics, what I wanted to do in this file is just kind of give you the context for the generics code. So the start of this file, there is no generics being used, and then we start using it because I'm saying here, look, this is how we would write our code if we were not using generics. But even before generics, if we go back to here, okay, I've got an array of strings, and we know from JavaScript, if I invoke the sort method on an array, then it will do what you think it does. It actually makes it changes this array and it sorts it in a particular order, and the sort method needs a callback. There's no TypeScript code really going on here now. Here's the callback, and it looks like what the callback is doing is it's comparing two strings, A and B. It's comparing their length, and so it's sorting the array of strings based on the length of the strings in ascending order. So the shortest string first and so on all the way up. That's fine. That's what the sort does, and we probably know that already. Here I'm declaring a function. Again, there's no generics being used here. It's called a string ranker. It's a pretty useless function, but stick with it. So I've got, it takes two parameters, it takes an array of strings, and it takes a callback, which I've called a ranker. Callback has to honor that, okay? And all I'm doing and it returns the sorted array. And all I'm doing is I'm calling the sort on my array that's passed in, and I'm using the actual ranker callback to, control the sorting for me. Right, so hopefully there's nothing new there. I mean, it just builds on what we've been talking about up here. What we've been talking about here, up here. However, I've got another function called, sorry. All I'm doing here then is I'm using this function, this string ranker function, because I'm calling string ranker, and I'm passing it indeed an array of strings, and I'm passing it my ranker function, which just takes a string and computes its length. Maybe ranker wasn't the best name for that. It's kind of the ranker assistant maybe here. Anyway, so that's what that's going to do is it's going to sort my array of strings by length. I could have another function that maybe sorts an array of strings based on the number of vowels in each string. And so in that case, again, I call my string ranker function, I pass it the array of strings, but this part here now would be a function that would go through the individual characters in the array and count how many vowels are in the string and return that as a number. This function that I've highlighted has to return a number. Why do I say that? Well, because that's what we said up here, right? It has to return a number. And the reason it has to return a number is, of course, that's because that's all the sort method can work with. Right. I've now gone on and I'm talking about, I want a function that actually sorts an array of person objects, which is very similar to obviously our function that sorts an array of strings. And this is where generics will be able to help us eventually. But for now, let's assume we don't know anything about generics. So I want a function that I can pass it an array of person objects, and I can pass it a function that will allow me to sort that array of person objects in a particular order based on maybe some criteria associated with person. So here, my ranker function is a function that takes a person and returns a number again. because that's what our sort is going to work with. By the way, person, I'll go back to the top. I'm importing person from a types file. And if I just briefly open up that types file, it's up in the 01 folder. Yeah, so a person has just as the first, last, and an age, and the age is optional. Remember that because that becomes significant. Okay, other than that, it's not terribly interesting. Sorry, no. Is it closed? I'm sorry now about this. Okay, I've got my person sorter, and I'm declaring some person objects here for myself. And then I'm invoking my person ranker function with my array of person objects. And I want, here's my function that is going to control the sorting, because that's all, sorry, now that's all the person ranker function does is it calls the sort on the array using the function that it was passed into it to control the sorting. By the way, we probably know that, probably should have said this at the very beginning, the way it does the sorting is it essentially executes this, which is always going to return a number. If the number is positive, then it means that A is greater than B. If it's negative, B is greater than A. If it's equal to 0, then they're of the same order within my array of objects, which are persons in this case. So clearly what I want to do, here I'm invoking my person ranker, and what I want to do is I wanted to sort my array of persons based on their age. But for good or bad, I decided that age was an optional property in a person. So it's possible that a person object may not have an age property for whatever reason. Now, if I kind of said, look, let's just ignore that. Look, let's assume they always have age. So I'm going to just take out this. Compiler is complaining down here. And essentially what it's complaining about is this function has to return a number. It's the function that's used for the basis of ranking. It must return a number, otherwise the sort can't work. But because age is optional, that means that the p.age, when it evaluates that, it could return null. That could evaluate to null. And that is not honoring the signature that my ranker function has to respect. So that's what this is complaining about down here. So it has worked out that age is optional, therefore this could evaluate to null. That's not a number, and this overall function in some cases will not return a number. So that's why I had to add on the extra bit of code. And I just arbitrarily decided if a person object does not have an age, then by default just return 30. Okay, it's a nice example of where optionals can not so much trip you up, but the compiler will warn you that your program could crash if you leave the code as it is. And in fact, it won't allow you. It won't allow you to go on. You have to correct that problem. And I've just, again, as I said, I've arbitrarily decided this is how I'm going to deal with that case. Right. Back to generic stuff. I have two functions here now. One called person, what did I call it? Person ranker. The other one is called string ranker. They both do essentially the same thing, but they work on different data types. Enter generics to solve that repeating code. So I've now defined a function which is badly named. Don't ever use the name generics in a function, but and it takes it's a generics function, and I've decided to call the type parameter t. It's a function that takes an array of t's, and it takes a function where or a callback that takes one parameter of type t and returns a number. This function always has to return a number for the sort to work, which I said before. The body of the function is, that statement there is, exactly taken from either the person ranker or the string ranker. It's kind of the exact same as this, in a way. So where are we? Okay. I do Command K, Command I, just as a matter of interest. Yeah, it's an array of t's. That makes sense. So this is my generics applied to a function. And here then eventually I'm calling the function. Well, probably a little bit overdone, but let's see what I'm doing here, sorry. Oh yeah, I'm calling my function. I'm passing it an array of person objects. I've also told the compiler to assign the type person to my variable t, and I'm passing it my my ranker function as before, and p is of type person, so it all matches up. This has to match up with this, so this has to be an array of persons, otherwise the compiler will change or will complain, sorry. There has to be a property of type that in P, and it knows that P is an object of type person, so on and so forth. Okay, so like we got there eventually, but here's an example of generics being used on a function. I suppose that's the overriding point of this example. And just to complete the picture, I'm also using it with strings, although there's something I'm doing here now that might seem a little odd. So here I'm calling my generics ranker, but I'm not specifying any type here. I did it in the case above, with person. I put person between my angle brackets here, but I'm not doing it here. And this is actually type inferencing coming to help. Or type inferencing, again, if I do Command K, Command I on this, you see it has, how is it helped? It's saying it's a function that returns an array of strings. So how did it work that out? Because that is right, this does return an array of strings, whereas if I go up to this guy, Command K, Command I. Returns an array of objects. Okay, so clearly it got that. It worked out it's an array of, sorry, an array of persons. It got that because I told it specifically, look, T is of type person, but I'm not telling it down here that T is of type string. But it inferred it, and how it inferred it was, well, it looked at the first argument, which is an array of T's, and T, because each of these elements in the array are strings, then it inferred that T must be of type string. Okay, so that's how type inferencing can apply to generics. And again, I'm sorting my strings on the basis of linked just for convenience. What I've got down here is an example of generics being used on types. So I've got a microphone type. I've got a speaker type. No generics happening there. Then I've got a box type, but I'm using generics. So box is a data structure because I'm using the interface data keyword of the interface keyword. So it's a box, but it could be a box of any type. And it's only when I create objects of type box that I will be specific about what type T should be. And a box looks like this is its structure. Okay, it has a shelf number and it has a content, which is an array of T's. And eventually then I get to use my generics type. So I have a box of speakers, and I've got a box that I'll have. Yeah, that's just one example of it. So this generics, again, is a really powerful programming technique, not unique to TypeScript. We see it a lot in classes, actually, generics being used. Okay. I think you would need to review that. If you haven't come across generics before, you would definitely need to go back and look at that code, play around with it to ensure that you at least can read and understand the code. Being able to, the real skill in programming when it comes to generics is identifying opportunities to use generics. Now, I do not expect you to be at that level for me for this module, but you certainly need to be able to read code that has generics in it. And in fact, we will see a lot of generics being used at the functions level, really. And on that point, where generics is, we will see it a lot is in relation to the whole promises idea. Where have I got it? Yeah, here. So I've got a separate file that is using the promises concept, and generics are nearly always relevant when we are doing any kind of asynchronous programming in TypeScript. Right, so here we go. I'm using a web API. Don't know if you've used it before. There's a web API called the Random User Web API, and if you invoke it, what it will do is it will return a randomly generated array of user profiles. And I've taken the time to actually declare a type based on a user profile structure. This is controlled by the actual web API now. In fact, if I just fast forward a little bit to let's see. Yeah, if I just click on that link. So the URL is randomuser.me/API, and the query string is results equal to 6. So when this request hits this web API, what it will do is generate, in this case, 6 random user profiles, I think it calls them, and return these 6 random profiles as an array within a JSON structure back to us. So if I click on that, okay, here's the response, and bump it up a little bit. So it's returning a JSON structure, curly brace. It looks like there's only one key in the JSON structure called results. And the value assigned to that key is an array. And you can play around with it later on, but look, that's roughly a, kind of a user profile. So what I've highlighted there, what I did was I just took one complete user profile. I don't know where it begins and ends. I'll have to take time to study it, and define a type around that. Okay, so just remember now that what it returns is a JSON object with one key in it called results, and that key has a value which is an array of user profiles. Okay. We'll come back to generics in a moment where that applies. So here's my type that I defined for myself, which is user profile. I've also, just for convenience, I've defined a type. This type here is the structure of the response from the web API. And as I try to illustrate, what it returns is a structure just comprised of one key called results, and the value is an array of this type, which is what I just defined up here. Okay. What's next? I've got a function that takes, sorry, give me a second now. Okay, it's an async function. It takes a string, which the string would actually just be the URL that you want to invoke. What the function does is it makes a fetch call to that particular URL. And I am, oh yeah, where am I? Look, here I'm saying that this function returns a promise of a structure of type that. And the structure that I've highlighted there is, all right, this thing is jumping around a bit in me, is this guy here, yeah? Okay, so it's just the generics thing that I want to, because we will see this a lot. It's a promise of a structure of type that, yeah. And the body, you've kind of seen this stuff before from your web API, web app dev 2 module from last year. Yeah, so that's just generics being used with promises. That's really why I'm demonstrating this at all. Okay, I'm just invoking my function here. And I'm, for just convenience, I'm processing. So users here, what is users going to be? Okay, command I. It's a random user response structure. That would make sense because that's what the promise said above. Promise of structure of that type. So it would be an actual instance of it. And all I'm doing down here is I'm what am I doing? I'm just mapping over the results part of the structure, which is my array of user profiles. I'm mapping over them, and I just want to dig out the person's name. Is that it? That's all I'm doing. I'm just digging out their name and where they're from, because that information is contained within the user profile. And so I should get an array with the users' names and where they're from in response. Let me just run it, I suppose. This is a bit clunky demonstration, but let's just go with it, I suppose. There are 3. Oh, we're on time. Oh my God. Okay, sorry. There are 3 promises. It doesn't work. Why doesn't it work? Okay, that's now. I wasn't anticipating that, obviously, but that's now because of this, the fact that I have to run these TypeScript programs not in the way that I would have liked to. And I don't think I'm going to go debugging what it's telling me here now. Experimental. Okay, I'm just going to ignore it. Sorry. If you run it in your own time, then you see the output. Sorry about that. Anyway, the only reason I'm including this code is because generics are used a lot with promises. I have a second example of another API. You know, it's much the same stuff again. It's just another web API. This one is called the placeholder web API. Let's see, and what the placeholder, see this one here. What that does is it returns, again, much like the random user, but you can control the type of randomly generated data that it returns. For example, you can get it to return randomly generated to-do lists. I think if I mouse over this URL here, see how you use this web API. So I'm actually asking it to return some to-dos for me. And I think it generates about 100 of them. Yeah, no, in this case, it just returns, the return is just a straightforward array, it looks like. You can see there at the top left, it's just a straightforward array of my to-dos. So there's no objects that I have to go digging into. And we can see what the structure of a to-do is there. So in my code, I define for myself a to-do type. And I'm doing much the same as before, right? I'm declaring a function that will take care of making the fetch call for me. This function, if I do, now I'm not specifying the return type of this. In the other case above, I was specific. I was saying it was a promise of particular structure. So if I do Command K, Command I, it's returning a promise of a to-do array, which is correct. Well done, compiler. Yeah, and so that's type inferencing kicking in there. Now I am giving the compiler a bit of help though. See this as clause here. The as keyword is a way of type casting in TypeScript. we're essentially telling the compiler, look, this is how you should interpret, in this case, what this returns, if you like. So interpret it as a to-do array. Typecasting is nice, but you shouldn't overuse it. Typecasting is an example of where you, if the compiler is telling you that it's interpreting something as the any type, you would use, for example, you could use typecasting to tell it, look, don't infer the any type, infer this type instead. That's quite kind of sophisticated, I suppose. But for now, all I'm really interested in is showing you that, look, it was actually able to infer that the return type is a promise of to-dos, and just, appreciate it for what it is rather than being necessarily able to fully understand how it worked all that out. And I'm just invoking it here. And again, I'm just doing some processing of my array of to-dos. I'm filtering out the completed to-dos. I'm just extracting the title of those completed to-dos. And because there are 100 to-dos returned to you, I'm just taking the first 5, and that's all I'm console logging the first 5. So again, I would encourage you to run this script yourselves just to see the actual results that are generated, the console logs that are generated. I will pause for questions, but I doubt the demonstration was a little bit clunky. But anyway, are there any questions about that? No. So, okay, we'll move on to the final slide, which is utility types. And as the name suggests, these are types that are provided by the language itself outside the primitives. Extra kind of utility types, which are often very useful. And mainly what these utility types are about is transforming one type into another type. And usually it's transforming one of your types into another type. Okay. And there are a whole bunch, and the transformation is performed by these utility types. And in fact, these utility types use the generic kind of angle brackets syntax again, as well, sorry. These utility types, there are many of them. There are many of them that are defined and kind of native to the language, that they're part of the language, but there's a whole community out there that have defined other utility types that we could find useful. I've never taken the time to look at those other community ones, but there's lots of them out there. We'll just briefly look at a few of the utility types that are built into the language itself. That would be suffice to get a sense of what utility types are all about. So we're on to here. Okay, taking it from the top, I've defined just a tech user data structure for myself. So, and we can see that all of the properties, well, sorry, 3 of the properties are mandatory, 1 is optional. That's okay. Now let's just supposing I also want a type which has the exact same structure as this, but I want all the properties to be optional. Okay. Now clearly you don't cut and paste. You could cut and paste and do it that way, but that's not very sophisticated. And this is where utility types come in. So there is a utility type called the partial type. And the way you use it is, as I'm showing you here, what partial does is, well, sorry, what you do is you give the partial utility type a reference to your type, and what it will generate, or it will transform your type into a new type where the new type has only optional properties, or all of the properties of your type are made optional. If I do Command K, Command I on this, you can see that name is optional, ID is optional, and so on. So everything is optional. So this is a new type that has been transformed from this type. So that's the partial utility type. Okay, there's just a little function that uses it there. You can look at that later on yourselves. Here I'm using the required utility type, which is kind of the opposite of partial. What required does is it takes the type that you give it, and it makes all of the properties of this type mandatory. So if we do Command K, Command I on this, we can see that the email property there is mandatory, where it was optional in the tech user type that it defined at the top. Okay, now all we're doing here is we're just defining additional types for ourselves, which we know we will need to use in our code. So that's required utility type. There's quite a lot of them, so I'm only picking a small subset. The pick utility type is where you have a type, but you want to define a new type which only has a subset of the properties of your original type. And the way you use pick is you give it the base type, if you like, and you list the properties that you wanted to pick out from that base type in order to create this new type. Command K, Command I tells us that this just email and name type has two properties. And as I did say at the outset, the utility, the syntax of using these utility types is like the generic syntax. I'm not sure if it's using generics internally, or maybe it's just a convenience that the designers of TypeScript decided to use the angle brackets. Either way. What's unfortunate about this one is that normally we interpret that as an or, but in this case you interpret it as an and. You want this property and this property. And you can have as many as you want to. You want them included in the new type. Just got an example of using the types there. You can look at that yourselves. Omit is kind of the opposite of pick, where you're telling it you wanted to omit these properties from this type, and that result is what's going to be the new type. You can use Command K, Command I on that. Record is a tricky one, really. Now, maybe if I just run this. So we have tech user. We know what tech user is from way up here, yeah? Now, if I just run my script, because it'll be a little bit easier for me to explain what record does first. So the script hopefully will run. Now, supposing, see this one here, right? It's array, is it an array? No, it's actually, it's an object where each entry in the object, its structure is like that. So I want to be able to define a type that sort of somehow explains the structure of this object. And we can see that in our case, the keys of this object must be correspond to the tech user ID type, and the value must correspond to the full structure of a tech user. Is it the full structure? Maybe only a part of the structure of a tech user. Okay, so the key has to be of type the tech user ID. The value, let's see what I do in the code actually. What structure is the value? Let's see. Okay, so the value is of type tech user programming, and I think that's defined earlier on. Go back to here. Tech user programming is, I do Command K, Command I. It's an object with a name and a programming, which is an array of strings. So it's a list of programming languages, let's say, that the tech user knows, right? And so that structure there, that's consistent with what I'm getting down here. Yeah, so where am I getting it? Yeah, here. There's a name property and there's a programming property. Sorry, let's see again. So with the record utility type, the first argument, if you like, the first parameter that you pass to the record utility type is the type of the key in our object that we see down here. So this is saying that the key has to be it has to be the same as the ID property of tech user. This is just using the subscript syntax that we have in JavaScript. This is an object structure. This is a reference to a key within that object structure. But because we're using this in the context of TypeScript and in the context of utility types, the way you interpret all of this is the type that the ID property is in tech user, which is string in our case. And this is defining the structure of the values associated with the key in our overall instance. And the values that I've highlighted down here do match up with tech user programming. Okay, I do Command K, Command I on this. So it's think of a record in relation to databases where you've got a number of records in a table. And essentially kind of that's what we're doing here. We're defining the structure of a table, where a table in this case is an object with lots of entries in it, but each entry has to follow a particular format. And in our case, the format is key is number, and the value is a structure of type tech user programming. And all I'm doing down here then is I'm just creating an instance of that type. Okay. And I think it's too late in this lecture now to try and step my way through this. I might do it the next day if I needs be. I'm not too concerned about record. We don't use it, but we do use the other utility types that I've mentioned. And you may come across utility types that you might find useful as well. Okay, I'm not terribly happy with how I explained that, but anyway, we'll come back to it if needs be. I don't think it arises in the lab either. So time-wise, okay, we're done, I guess. So I'm gonna wrap it up. So conveniently, we've finished bang on at the end of our TypeScript. That's the last slide in our TypeScript set of slides. So you are now in a position to complete the lab. And we can see that the lab has sections on functions, which you've done, maybe optionals, type aliases, generics, and there's a utility type section as well. But there's quite a lot to get through, actually. I have set tomorrow week as the completion date for this lab. I think you should be able to get work your way through all of it between now and then. And we have a lab session next week anyway. Okay, I'm going to leave it at that for now. Again, I'll pause for any questions, whether it be specific to what I've been talking about or more generally.
Hey,
No?
Dermot. That note or the script files you were working with, is there any chance you could make those available for us?
Well, they are, you see, if I go right back to the very first slide. See there at the bottom of the slide where the source code.
My bad.
Yeah, I mean it's extremely important that you spend time playing around with that source code. That's really why I'm using it as the basis for my lecture and why I'm providing it to you, because it certainly does. You know, you need a month to play around and be able to be reasonably competent with TypeScript. We don't have a month though, unfortunately. So I'm being very specific in terms of parts of TypeScript because there's lots more to it that we haven't looked at all. But I'm being specific with the parts that we will need from here on in, because it's only a tool that we're going to be using to implement infrastructure as code. Yeah. Okay, so that was the answer to your question. Thanks. Anything else? Right, I'll leave it at that. So I will eventually get around to, I've actually started working it this morning, getting around to making these recordings should you need to go back over them or parts of them, and I'll make them available on the website. If you go into this section here, okay, this is just a dummy one at the moment, but it will eventually bring you to specific YouTube recordings. That's fine. I'll talk to you sometime next week, and you can contact me on Slack if you need to. Okay, bye-bye.